All right. We know from experience that y equals mx plus b is going to give us a linear equation. We also know that changing m and b will change specific characteristics of that line. Today we're going to focus more on the exponential family. The very simplest form, our equations of exponential functions are y equals b to the x power. So by experimenting with different values of b, we want to try to mimic the equations that you see below. Now they're not going to be perfect, there's going to be sort of similar. So there's a Desmos graphing calculator that you can use. If you're really stuck, here's a couple things you can think about. Well, first of all, here, this is going to be, we'll give this equation 1, equation 2, and equation 3. So equation 1 has maybe a more dramatic growth, which means that our base is probably going to be larger versus 2, which has a slower growth. So then our base would probably be a little bit smaller. So maybe equation A is something like y equals 5 to the x power, where equation 2 is maybe y equals 2 to the x power. Now, equation 3 is a reciprocal, not a reciprocal, a reflection, or instead of increasing, we see our values decreasing. So that would mean our base, b, would have to be something smaller than 1, but greater than 0. So maybe, let me write that a little bit better, 1/2 to the x power. Now, you could have had something here like y equals 1/3 to the x power, or y equals 2/3 to the x power. Any of those would work. And what I want you to just notice is that the relationship between equation 1 and equation 2 is equation 1 should have a larger b value than equation 2. And you can play around with the Desmos graphing calculator to sort of experiment a little bit more.